All right, how we doing, kids? Hopefully you're not going too nuts being locked in the house every single day, staring at the same four walls over and over again. All right, anyway, so I did post the answer to the sample that I asked you to try as far as quantitative aspects of heat transfer, right? Okay, so I want to look at a problem like this. This one's going to be a little more intricate, so that's why I decided to do a video on it. And it says 572.4 grams of antifreeze, which is ethylene glycol, or 1,2-ethane-diol, or the stuff that keeps your car from freezing up. We have 572.4 grams of antifreeze at negative 30 degrees Celsius, so very cold, combined with 1,483.6 grams of water at 42 degrees Celsius. I used nice even numbers for this. What is the final equalization temperature, like after I pour the one into the other? All right, so let's see what we do know, okay? I got T1 for the antifreeze, right? That's good. And it's kind of like, all right, so I have this antifreeze at negative 30, and then I have this cup of water at 42, and I pour them together, all right? Now, what in the last two problems, it said the temperatures equalize at, and we said that equalization temperature was T2 for both things. All right, but I don't have that equalization temperature. I'm trying to find it. All right, so here's what I know. All right, so T2 is our question mark, our variable. If I said to you, all right, what do I know about this final equalization temperature? Raise your hands. Nobody wants to try it, huh? You're awfully silent. All right, anyway, here's what I know about the final equalization temperature. I know it's the same number for the water and for the antifreeze, okay? That's the first thing I know. The second thing I know is, maybe you're thinking this and maybe you're not, but you're gonna know it now. The final temperature is the same for both things, and it has to be somewhere between negative 30 and 42, okay? Because the water is gonna warm up the antifreeze, and the antifreeze is gonna cool down the water. So the answer's gotta be somewhere between negative 30 and 42, and I don't necessarily mean the middle, right? So if I got an answer like 65 degrees Celsius or negative 98 degrees Celsius, I would know I did something wrong. Okay, but here's what is true still, all right? And that is, we have two Q values. A Q value for the antifreeze, which I'm just gonna call Q anti, plus Q water. And if you remember, the sum of all thermal energy change in a system is going to be 0. Okay, so look, the antifreeze is colder than the water. That means the antifreeze temperature is going to come up. It's going to be gaining heat. The antifreeze value is going to end up being positive. The water value is going to end up being negative. Okay, and what we know about our Q values, at least that I tried to explain to you the other day, is that Q is just M times delta T times Cp for the antifreeze, and M times delta T times Cp for the water. Okay. I'll be all right with that. Oh, you know what? I didn't give you the Cp of water, but remember, it's all over your packet. It's 4.184. Now look, as far as your temperature goes, if you plug in Celsius for antifreeze and Celsius for water, your T2 will come out in degrees Celsius. You don't have to worry about changing it or anything like that. All right, well, let's see what we know, and let's start plugging it in. All right, the Q antifreeze is M delta TCP. The Q water is M delta TCP. Okay, but you gotta remember, delta T is two things, right? Delta T is T2 minus T1. It's not T2, it's not T1. It's not T1 minus T1. It's not T2 minus T2. It's T2 minus T1. That's delta T, the change in temperature. So let's start plugging in the numbers that we do know. Okay, Q antifreeze, the mass of the antifreeze. Ah, look at that, it's the very first thing. 572.4 grams. Now, if you were listening to my spiel a little bit earlier, you would have heard me say that delta T is T2 minus T1, and that the equalization temperature is T2 for both. All right, well, I might not know what delta T is, but I do know it's T2 minus T1. So, okay, so the delta T for antifreeze is going to be T2, which I don't know, minus T1, which is negative 30 degrees Celsius. Okay, T2, I don't know, minus T1. Okay, CP of antifreeze, I gave you that right there. Okay, so the CP of antifreeze, 2.39 joules per gram degrees Celsius. I might have given it to you in Kelvin, but it doesn't matter. Okay, so now we got the Q value for the antifreeze. All right, so let's go. Let's get Q water. Okay, Q water plus. All right, do we have the M value for the water? I believe we do. 1483.6 grams. Okay. Delta T for water. Delta T, the change in temperature, is T2 minus T1. Okay, we got T2, which we don't know, minus T1, which is 42. So I'm going to do T2 minus 42. I'm not going to write the Celsius in because I'm running out of space here. And the CP value for water is 4.184. Okay, so let's 4.184. And I'm going to set all of this equal to 0. I couldn't write over here because I'd end up writing on my paper towels. All right, so this is what it looks like. We got, I'm not going to carry the units with me anymore because it's going to come out in degrees Celsius because everything is going to end up canceling in the end. All right, so I got my M of antifreeze, my delta T of antifreeze, T2, which I don't know, minus T1, which is negative 30, okay? And then I got 2.39 is the antifreeze CP, plus Q water. What's Q water? M delta T CP. Here's the M of the water. The delta T is T2, which I don't know, minus T1, which is 42, and then 4.184. I'm going to set it all equal to 0. All right, so here's where the math might get a little bit confusing. The first thing we're going to do, look, 2 times 3 times 4 is the same as 3 times 2 times 4, is the same as 3 times 4 times 2, is the same as 4 times 3 times 2, right? It's all the same. Okay, so M times delta T times CP is going to be the same thing as M times CP times delta T, right? I mean, it's the same thing. Just think about it. If you don't believe me, put it in your calculator. All right, so let's do this. Let's do 572.4 times 2.39. All right, and when I get that, I get 1,368.036. I'm going to call it 1,368.04. All right, I'm just kind of rounding it a little bit for the time purposes. All right, well, that's just M times CP. We also have to multiply it by this quantity delta T. All right, T2 minus negative 30. Wait, minus negative. My lips are so chapped. Yeah, there's my random personality again, kids. Minus negative plus. Okay, so T2 plus 30. Right? Think of it this way, right? If you subtract negativity, right? If you subtract negativity from your life, you're going to become more positive. There you go. See, life lessons with Starach. All right, so M times CP is this times this quantity delta T. All right, now plus. Okay, so I got my son's iPad here because I left my calculator in my classroom. 1483.6 times 4.184, which is the CP of water. 6,207.38. All right, 6,207.38, right? Well, this time it's going to be times the quantity T2 minus 42. Oh, yeah. Okay. T2 minus 42. How's your angle work? You doing okay? Okay. He's doing angles, right angles, straight, acute, obtuse, reflex, and all that other stuff. Okay.
You could use this.
Yeah, it's okay. You can use it. All right. And this is still going to be equal to 0. All right. So now I think when you get to this part, it's not going to be too bad, right? So we have to do the combination step now. So let's bust through those parentheses by using that property. That property, it begins with a D and ends in iv. Distributive. All right, let's go here. 1368.04 times T2. Well, I don't even need a calculator for that. All right, well, 1368.04 times T2 is 1368.04 T2. And then times 30, we get 41,041.2. All right, so there, I just busted through that, John, and I got rid of my parentheses. Okay, so this is here. Now, plus 6207.38. All right, let's do 6,207.38 times 42. This is going to be a lot. All right, so 6207.38 times T2 is 6207.38 T2 minus, now look, it's going to be minus here because it was minus positive. This was minus negative. Minus negative is plus. Minus positive is still minus. 267,710. 267,710 equals 0. Okay? All right. Let me just make sure I got that right. Okay. So, now we can do our combination step. Look, I got this much T2 and this much T2. All right? That's why 4x plus 5x is 9x. But 4x plus 5y is not 9. It's like cats and dogs, right? Remember from the beginning, you had 4 cats plus 5 cats is 9 cats. But 4 cats plus 5 dogs is not 9 of the same zebras. You know what I mean? Okay. Or as they say in Britain, zebra. All right. So let's combine our T2. We got 1368.04 plus 6207.38. And I get 7575.42. 7575.42. I have that much T2. Right? Okay. Well, now we got positive and negative, right? So we got 41,041.2 minus 267,710 equals negative, right? So minus 226668. Whoa, 22668.8 equals 0. All right, so let you kind of check that out for a minute. Okay, and lastly, look, I'm going to add the 226,000 over to this side. I'm just running out of room. So, you know what I can do? I can kind of continue it up at the top here. Let's do this. Let me kind of erase this and I'll continue where I'm going here. All right. So if I add the 226,668.8 over to this side, it's going to make it 0 here. So I'm going to be left with 75.42 times T2, if you want to keep that in parentheses, you can, equals positive 22668.8. All right, now we're one step closer to the end. Let's divide by 75.42, and divide by 75.42 on both sides. And we will get it canceled out there. And the only thing left is T2. Okay, so let's see what happens when we take that number and divide it by 75.42. We get 29.9. Did I punch that in right? Hold on. I think I made a mistake somewhere, kids. Hold on. Let me make sure. 222. Nope. 668.8 divided by 29.9. I think the answer should have been closer to 29. I might have rounded wrong somewhere. Let me make sure I got these numbers right. 6207. I got the feeling I wrote one of the numbers down. I apologize. Times 42 equals 26710. Yeah, 26710 minus 41 equals 219. Okay, here's what I messed up here. Sorry, everybody. This number's wrong. Ugh. I think I punched it in the calculator wrong. It's 219,669. All right, that's where I'm wrong. All right, so basically, let me change this here. Now we should get the right answer. I thought the answer looked a little funny, but hey, that's what happens when you don't have your own calculator. 219,669 divided by 75.42. All right, that's where we're wrong. Now what we're gonna be left with is T2, and when I divide this by 75.42, I get 28.99, which is 29 degrees Celsius. So there we go, okay? Yeah, I made the tiny mistake here when I was adding them. It's 41,041 minus 267,710 is 219,669. All right, so then you add it to the other side of the zero. It comes over here, and then you divide by 75.42. You'll get your T2 on its own, and 29 degrees Celsius, okay? Sorry about that, but that's what happens when you're trying to use a Google calculator for your stuff. All right, so I'll be posting this video soon. Hope everything's going well with you guys, all right? See ya.